Hello class. Yesterday we looked at chapter 12, rate of change, and then we did an example with that. So today we're going to continue that. It's pretty much what we're going to be doing all week. If you looked on the posts section for your team, you see that I kind of gave you an outline of the week. I'll be doing that every week on Monday, so you kind of see which days we're having an assignment due and when the assignment is due. So today you're going to have a problem assigned to you that will be due with tomorrow's assignment. So you'll turn that in with tomorrow's assignment page. Okay? So it's going to be a rate of change problem. Your assignment today will be very similar to the example we did yesterday. Okay, so the one with the balloon, hopefully you took notes on that like you should have. That will help you for today's problem if you need it. And once again, if you still need help, get with me on Teams. Okay, so let's go ahead and look at an example for today. Like I said, all these rate of change problems are very similar, same style, same method. You're still going to use that formula to solve them. You just have to learn what to pick out. Alright, so if we're doing rate of change, then we know we're going to have to deal with the rate of change equation. So dy dt equals dy dx times dx dt. Okay, how do you read this? Remember, what does dy dt mean? It means how the rate of change of y. Okay? And the same thing for dx dt. It means the rate of change of x. And then dy dx, that's just the derivative of the equation y, or whatever equation you have in your problem. Okay, so first step is always write down this equation because that's what you're going to need. Second step is always find out what my equation is, what my function I'm dealing with is. So you read the problem. The radius of a circular disc is increasing at a constant rate, so there's some of those keywords, of 0.003 centimeters per second. Find the rate at which the area is increasing when the radius is 20 centimeters. Okay, so we know we're dealing with area. Area of what shape? A circle it is, so area of a circle. So we know that is going to be important. So the area of a circle is pi r squared. So that's going to be my y equation. So my y here is a, and which is area, and what does area depend on? Radius. So this is my y, this is my x. Okay, so I can rewrite it as dA dt is equal to dA dr times dr dt. Remember, dt never changes. You just change out your y and x based on what you're dealing with. In this case, it's area and radius. Okay, now we go through and we find out which one of these we're given, which one of these we have to find, and which one of these is the derivative. Okay, remember that process. Every single one of these questions, one of these variables is given straight from here. So this point 003, that's one of these. dA dr, that's going to be the derivative of this. And then one of these we're trying to find. Okay, so let's read this. A radius of circular disc is increasing at a constant rate. Okay, so that's the value, but which one of these is the value of? Constant rate, so that's dt, so it's going to be one of these. Now we're talking about rate of change of area or rate of change of the radius. Well, first two words is the radius has a rate of change of this. So that is going to be 0.003. Okay. So what about this dA dr? So it's the derivative of a with respect to r. Well, here's a, so it means we need to find dA dr. So take the derivative of this, bring the 2 down, we get 2 pi r. Okay. Now this is still a variable, so this is where you always check and make sure to see if they give you a value for r. That way you can plug it in and actually get a number here instead of something with variables. What did they give us? The radius is 20. So we will just replace r with 20. So 20 times 2 is 40 pi. Okay, so that goes here. So that means we're probably trying to find this one. So let's make sure. find the rate, so that's dt, at which the area is changing. So yeah, we're trying to find dA dt. Okay, so now it's as simple as just doing 40 pi times 0.003. In these cases, when you're given pi, you can always just leave pi as pi, and you just multiply the two coefficient numbers. So you would do 40 times 0.003. Now 3 times 4 is 12, and 3 times 0 is 0, so we have 120, but then we need to move it over 3 decimal places. So if you do it in your head, you get 0.12. If not, use your calculator, and don't forget to tack on the pi. Okay, so that is pretty much it. That's all there is to that problem. Okay, so once you start to get these process down of writing out an equation, figuring out which equation you're dealing with, whether it be area or rate or volume or whatever it might be, you find out which one's given to you. That's when you will always have to take the derivative of some equation and then find out which one you're trying to solve for. And then just plug in your values, like 20 for R. Okay, so you compare that to yesterday's example and you'll see the process was exactly the same. And for your assignment today, your assignment is posted or it's attached on the assignment page as a PDF. So if you have any questions with that one as you're working through it, just message me on Teams. Alright, thanks guys. Have a great day.